Good afternoon, everybody.
Good
Please, I'm
afternoon.
Gladys Anye-ngameena, a graduate from the University for Development Studies, who studied biochemistry, and I'm passionate about medicinal chemistry and drug discovery. So, my research study is based on the comparative analysis of the antioxidant activity.
Look at the camera there, okay.
Okay. The comparative analysis of the antioxidant activity and phytochemical constituents of Alstonia bonae stem bark and leaves using various extraction methods. Okay, so Alstonia bonae, it's commonly known as nyamidua in Ghana here, preferably Kumasi. It's used as a medicinal herb for various ailments because of its high phytochemical constituents like phenolics and then flavonoids and tannins. So they usually use it to treat ailments like malaria and then things. And usually in the local homes, they boil it and then use the extract. But in this study, we had to conduct an analysis using different extracts like ethanol, and then we're also going to use aqueous water too.
All right.
So the specific objectives of this study is firstly to identify the phytochemical constituents that are present in the extracts of both the aqueous and the ethanol extracts of both the stem bark and the leaves, and then we will now quantify the phytochemical yield that is present in both these extracts, and then we will now use that one to determine the antioxidant activity, how they scavenge radicals in the system. So we utilize both qualitative and quantitative analytical methods to provide comprehensive characterization of the extracts. And then, so the sample was collected from the farm, like in the farm, we went with some locals there, we took it and it was shade dried under shade. We didn't dry it directly under the heat. We dried it under shade and then it was grinded and then it was sieved, obtained finer particles for easy extraction. So we use the maceration method to, with standard protocols by Santos et with little modification with the volume and then the mass of the samples of the leaves and then the stem bark. So after the phytochemical qualitative analysis, these are the results we had. So we were able to determine that there were phenols, flavonoids, tannins, alkaloids, terpenoids, and saponins in all the various extracts of the stem bark and the leaves. And then we quantified only the phenols, flavonoids, and then the tannins. Please, next slide. So this is the quantification of the total phenolics within the various extracts. So from the bar chart here, we can see that ethanol leaves extract, they contain the highest total phenolics content, followed by ethanol aqueous leaves extract. So realize that the leaves have higher total phenolic content as compared to what the stem bark because of the photosynthetic activity that occurs in the leaves of the plants. Next slide. The total flavonoid content here too, we can see that when it comes to the ethanol extract, they are higher as compared to the stem bark. And then the ethanol extracts too. So the ethanol is able to extract more of the phytochemical content due to its high solubility as compared to the aqueous extract. And the same too goes for total tannins. So here, total tannin, the ethanol leaves too has a higher content as compared to the aqueous leaves, and then the same goes for the ethanol stem bark and then the aqueous stem bark of the Alstonia bonae plant. So when it comes to the antioxidant analysis, so we did it in serial dilutions of different volumes and concentrations to be able to determine the increasing radical scavenging activity of the various extracts. So we added the serial dilution, the concentration of the extract from 3.125 to 50 microgram per ml, and then we added it to 4 ml of freshly prepared GPA solution, and then it was placed in a dark environment, and then the absorbance was read at 517 nanometers, and then So this is the radical scavenging activity. So you can see that from the list volume here with the GPPH, that's a 3.12 microgram per ml. So we can see that with the ethanol leaves, it's increasing across the serial dilutions concentration. So indicating that the more you increase the amount of GPPH, that is the free radicals, the extract is able to scavenge the free radicals that are present in the GPPH, indicating that the more the phytochemical yield in the extract, the more the antioxidant property, hence giving these extracts the ability to have these therapeutic effects that are used in treating ailments in terms of antimicrobial and then other stuff. So this study was, we just did the phytochemical content and then the antioxidant activity, but we didn't do in vivo studies to characterize and then determine the potential of this therapeutic effect. So we recommend that further research should focus more on in vivo studies to determine these specific therapeutic potentials of these extracts. Thank you.
Thank you, Gladys. Thank you so much. We would like to get feedback. Dr. Akaitete, would you like to start?
Yeah, Gladys,
Yes, please.
a very good presentation.
Thank you.
The fluency was there. Your objectives were well spelled out. I saw that you used the mixed method. When it comes to the results, the quantitative were well spelled out through your graphical presentation. I didn't see anything on the qualitative. You said you used the quantitative and qualitative. What did you do under the qualitative method? And then, where did you also conduct your study? Where did you conduct your study?
The study was conducted at University for Development Studies, Nyampala campus, Spanish laboratory. And the qualitative one was to determine the presence of the various phytochemicals that were present in the various extracts. And then the quantitative study was to determine the content, the yield, the content that was present in this extract. So the qualitative was to determine the presence of the phytochemicals that were present, and then the quantitative was to determine the content.
And so how did you determine the presence? What was the outcome?
So we were able to determine a lot of phytochemicals, that is saponins, terpenoids, but we only quantified only 3 of these phytochemicals. So I think
Which were?
we quantified total phenolics, total flavonoids, and then total tannins. But we identified other phytochemicals too.
Okay, so like Anti-Patient Oboy said earlier on, in coming out with such abstracts, you talk about what happens with the qualitative, what happens with the quantitative. You understand? So that somebody, even if the person did not get the opportunity to listen to your presentation, can read everything out in your abstract. You see, abstract talks about everything, whether you are able to present or not. You've done a very good job. I have said that this is just a beginning, so you have situated your work very well. And let's hear on the average, everything is on point for now. Thank you.
Thank you. Dr. Abo. Should unmute to use.
Thank you.
Okay.
The understanding of the qualitative, I didn't really get what you said you did about the qualitative. Is it that you went to the field, took a quadrant, and then decided what was there concerning what you were looking for? Or I don't understand that. Can you come again for that? So, otherwise, it's a good presentation, but let me just understand what you did for the qualitative.
So for the qualitative analysis, And because of the limit of the number of slides, I had to pick that one out. So, uh, so for the qualitative analysis, after we got the extracts from the various extraction methods, we ran some phytochemical analysis using biochemical tests to determine the presence of these various phytochemicals that were present in the various extracts of the stem bark and the leaves.
Well, I I don't know what to say about that.
So it's a whole lot of tests that we ran in the lab to identify the presence of these phytochemicals, and because it was a whole bunch, it will stretched the presentation time. That's why I just summarized everything.
Okay, let me leave it there. You said earlier that the community or the people use it for, I think you said malaria.
Yes, please.
So for what you've done so far, with the results you've got so far, is there anything that will help the community going forward, or you are yet to do more tests?
Yes, please. So we did an in vitro studies. So we are hoping that in a situation where maybe we would like to continue it, then we would try to do more in vivo studies to be able to know the specific therapeutic potential of these phytochemicals that are present in the plant stem bark and the leaves.
Okay, so work is still going on.
Yes, please.
Okay. I thank you very much. Your presentation was very lively and up to the point. So congratulations.
Thank you, ma.
Thank you, Dr. Abu. Dr. Jembibi.
Good work done. Forgive me if I make some comments that are not coming from an informed position because of your background. So I've already apologized. I hope you forgive me if I do.
Yes.
Okay, so it's a good presentation, but going forward, irrespective of your sample size and the numerous results, just try and look at the high points. Okay, issues that will make your work stand out, and then you bring it.
Okay.
Okay. So on the whole, I would say the background and aims are clear,
Yeah.
but the methods and the results section sometimes reads like general comments rather than clearly separated components. So you have to try and bring that clarity there.
Okay.
And then the progress from background to aim to methodology to results is sound. Though one sentence about ethanol extraction feels slightly repetitive between the intro and then your results. So take a good look at it. And then the comparative analysis of plant parts and solvents is standard, but still valuable, especially for a regionally important medicinal plant. This work is very relevant for phytochemistry and then more especially looking at natural antioxidants development and then local medicinal plant utilization. I think when you're able to do the in vitro, I'm sure it will help us since these days we are all talking about organic and herbal treatments to various ailments. I think if you're able to carry on with that research, it's really going to help us. I would also have something little to help improve the work. If I say it's just like I've apologized, if I make a suggestion which doesn't sound too medical, you forgive me. So if you are, just like I mentioned earlier, if you're able to provide at least one quantitative results, I'm sure it will help, and then try and reduce the repetition about ethanol giving higher phytochemicals by stating it once more clearly under the results section. I think it will make your work more concise.
Okay.
And then you also need to clarify the tense in the last sentence of your abstract.
Okay.
Okay. Basically, I think generally, I think it's a good work, especially looking at the antioxidants parts and local its utilization within our local communities and our quest to move away from orthodox medicine to non-orthodox medicine. So I think try as much as possible if you can carry out the in vitro test or research, then we'll be able to add this one to our pile of natural antioxidants we already know.
Yeah.
Thank you very much for your presentation.
Okay.
Thank you too, Dr. Jembibi. So I'd like to ask, how do you introduce the antioxidants to the solutions?
The solution.
Uh,
So the antioxidants are present in the extract.
uh-huh.
So, and then the DPPH, it's an assay. So they include they have the free radicals.
Okay.
So the free radicals, they are like the molecules that are in our system that are not supposed to be there.
Uh-huh.
So these antioxidants that are present in the extract will come in when it's introduced into a DPPA which contains these free radicals, because we can't. It's not how do I put it? It's still an experiment, so it can't be used on us. So we have to find an alternative that has these free radicals, and the DPPH has it in its assay. So when the extract is introduced into the DPPH, it will what move up to what bond or pair with the free radicals, which will help you to know that there's what a radical scavenging activity. So they are pairing or bonding to what.
Okay.
That's how it is.
Thank you. Thank you so much. Does anyone have a question for Gladys? No? Or you don't want to be asked questions, or you won't ask? All right. Can we please give Gladys a hand?